So hello everyone. So let's solve Math A 2014 question 1.4. So this is an interesting question and I'm going to solve it here, and then I have another question that is really similar to this from my book, and I'm going to solve it without calculus and then with calculus. So it not all in this video, I think, but there will be three solutions and three videos probably, or maybe I joined them in one video, I don't know. Let's see. Regarding this topic, so because it is analytic geometry with distance and minimum, so I think it might it's the question that I have is fun, so later we are going to do it. So let's read the question. There is a circle with a radius of 2 where the center is at the origin and a line 3x plus 4y minus 12 equals 0 in the plane. The minimum distance between a point on the circle and a point on the line is so for this question, the way that I solved it, and this is why I want to put another solution to the other question with calculus, because I think it would this might not this might be just working in this question because it's a specific case. Let's just start solving. Already 1 minute and they didn't start, so so the circle has radius 2 and is in the origin. So if you remember, the equation of a circle is x minus x of the center squared plus y minus y of the center squared equals the radius squared. So it's in the center, so here's 0 and here's 0. Okay, so x squared plus y squared is equal to, the radius is 2, right? Yes, 2. 2 squared is 4. So this is our circumference equation. So how would this be in the plane? So it would be like this and here, and then will be something like this. Okay, so now and here's 2. Okay, this is 2 over here because the radius is 2. So 3x plus 4y minus 12. So for the line, 3x minus plus 4y minus 12 equals 0, right? This was our line. Yes, this was our line. So for this line, let's make the y alone, taking it over there. So actually let's take these to the other parts, the same thing, just let's isolate y. Okay, so 12 minus 3x divided by 4, right? So y is equal to minus 3 divided by 4x plus 12 divided by 4 is 3. Okay, so 3. So this is the linear coefficient, so it tells you where we are cutting the y-axis, so it would be here, right? So this is 3 because over here is 2. Okay, and then we can find where it cuts the x-axis. Let's say that minus 3 divided by x plus 3 is equal to 0, so that we can find where the y is 0. Okay, so x is equal to 4. Okay, so over here it cuts over here in 4. Okay, so it's basically like this. I'm just going to take them out of scale so that the line so that we can show the line bigger. Okay, so it's something like this. Okay, so 4, 3. Okay, and here we have the radius 2, and then we have this distance over here. Okay, so we have this distance over here. Now look, you might argue, you might say like, well, the line could have been like this. The line could cut maybe, and I think that with calculus, solving by calculus is the perfect idea, but this also gives a good solution. So I want to show it, and then I'm going to do more videos about this question. Okay, so let's find the distance between this point, the center point over here, okay, and this line. Okay, so I'm going to find the distance between this line and the point 0 0. Do you remember from analytic geometry the formula for the distance between a line and a point? So the distance is the model of a of x of the point plus b multiplied by y of the point plus c divided by the square root of a squared plus b squared. Now remember, the 3 is our a, the 4 is our b, and minus 12 is our c. Okay, so this is a, this is b, this is c, and this is our x, and this is our y. Okay, so our distance would be the model of 3, a is 3. Okay, so 3 multiplied by 0 plus 4 multiplied by 0, because the y and this is not 40. Okay, this is 0. 4 multiplied by 0 plus minus 12 in a model, because it's the distance, so we only want the model. So a squared is 3 squared is 9 plus 14 squared is 16. Okay, so the distance is, so this 3 multiplied by 0 is 0, 4 multiplied by 0 is 0, so the distance is equal to minus 12, but it's in model, so we only want the 12. Okay, so the distance is 12 divided by 16 plus 9 is 25, in the square root is 5. Okay, so what is this distance over here? It is all this distance. It's from the point to the line. Okay, but what is the question asking us? It is asking us the minimum distance between a point on the circle and a point on the line. So what is the distance he wants? He wants this distance. So all of it we found. This part over here is r. So the part that we have left is what? So the thing that he wants to know is equal to the d minus r, the radius, right? So our question is d is 12 divided by 5 minus r. So r was 2, right? So our answer is going to be, well, here we can multiply by 5 up and down, so it will be 2 divided by 5, right? So this is our answer. Now look, this is the answer, the right answer, but I can understand if you argue like, well, maybe the distance is like this, and it will still be the same. Okay, because the line that will be the point that will be the nearest will be going cutting over here. What do I mean by this? I think like the calculus, the finding the value is, you can do it. I think that the idea is more important. So what do I mean by this? So look, because like here I drew the line like it was parallel, so it would be beautiful, but it doesn't need to be like this. So let's say we have a circle here and the line was like this maybe. So instead of our minimum distance would be like this, it would be like this. So the same thing would be still valid. We could find the equation for this line, find the distance between the point of the center of the circle to this line, and then we know the radius, so we can subtract. So this, I'm not 100% sure that this method applies for everything, right? But every time I used it, it was correct. So I'm going now to solve the questions from my book with this method again, and then with calculus. Okay, so by a derivative. So that's it. But just again, you see, the minimum distance with all these are radius, so they are all always perpendicular. Okay, so just let's go to the next question.